Hello and welcome to today's lesson, which is all about the product rule. Now, the product rule refers to when we differentiate a function, which is actually two functions multiplied together. That's what a product is. Okay, so what the product rule says is that if you have a function which is two functions multiplied together, then the gradient function dy by dx is equal to function u multiplied by function v differentiated plus, make that a bit clearer, plus function v multiplied by differential function of function u. Okay, all right, so let's go and put that into practice. So we have an example here, and you can see that we have two functions that have been multiplied together. Okay, the first function u, is x squared, and the second function that we've got is x cubed plus 1. Okay, so what we have to really go and find is du by dx and dv by dx. Okay, so what we get is, in this case, 2x, and in this case we get 3x squared, or plus 1. That nothing happens there, does it? It's just a constant. When we differentiate, it becomes 0. Okay, so going back to this, what we get, and in fact, you know what, I'm going to just simplify this, going back to it. It's actually uv dash plus vu dash. I do write that down because it's a lot quicker than writing all these dv by dx and du by dx. Okay, so uv dash plus vu dash is much more efficient. Okay, so what we're going to do then, dy by dx, which is the differential, the whole function differential, which is equal to uv dash plus vu dash. Okay, let's put it together. U is x squared, v dash, this is this one, v dash, and this is u dash. Okay, so this is 3x squared plus v x cubed plus 1 multiplied by u dash, which is 2x. Okay, now it's potential here to simplify things, I think. So 3x to the power of 4 plus, what have we got here? We've got 2x to the power of 4, and we times it out, plus 2x. So simplifying that, actually, we could gather up these like terms. We get 5x to the power of 4 plus 2x. Okay, all right. So far, so good. I hope so. All right, next example, EG2. EG2. Okay, so again, we've got, I'll do a different color this time. So we've got u this time being equal to 3x plus 1, v being equal to x squared plus 5. So let's do it quickly. U dash this time is equal to 3, and v dash is equal to 2x. Okay, so let's, oh, actually, I don't know why I'm writing it down again. Oh, actually, this is quite longhand, isn't it? I'm going to do it shorthand again. So uv dash plus vu dash, which is equal to 3x plus 1 multiplied by 2x. Clear it, plus vu dash, which is x squared plus 5 times by 3. Okay, let's simplify that. So what do we get? 2x multiplied by 3x is 6x squared plus 1 lot of 2x, which is just 2x, plus 3x squared plus 15. I can definitely simplify that. 9x squared plus 2x plus 15 when I gather up like terms. Okay, fantastic. Hopefully you're on board there. And EG3. Let's have a look. Why not a different colour? Let's go for it. So this time, EG3. Okay, fairly straightforward. I think we're getting the hang of this. You might want to beat me to it here. So we've got two functions. We've got x squared. We've got 2x plus 3. Again, all we have to do is u dash and v dash. So we get 2x. And we get 2. So dy by dx is uv dash plus vu dash, which is equal to uv dash is 2x squared plus 2x multiplied by 2x plus 3, which is equal to 2x squared plus 4x squared plus 6x. Simplify it, 6x squared plus 6. You know, there's potential to go and factorize if you wish as well. You don't have to do anything like this, but just to simplify it again, perhaps. Nice. Okay, and the last example, this one is where you might be thrown in a bit of a chain rule as well. Okay, so e.g. 4, so let's do this one in pink. Why not? Okay, u equals 2x and v equals x squared minus 1, excuse the handwriting, to the power of 5. Now you can see here we've got a function within a function, much more complicated than this one because this one's really easy to differentiate straight away. I just get 2. Now this one I'm going to have to think about as if I was doing a separate chain rule example. Okay, so if I was doing the chain rule here, the function within the function is x squared minus 1. And so y, if we write that in terms of u, is u to the power of 5. Now here, du by dx would be equal to 2x. And here, dy, there's an arrow, dy by du is equal to 5u to the power of 4. So if we put the u back in, is x squared minus 1 for u, 5x squared minus 1 all to the power of 4. So what we get then for v dash is when we multiply these two things together, this one and this one. Okay, so what we get is 5 times 2 is 10x, x squared minus 1 all to the power of 4. Okay, now obviously we're not there yet, we've just got our 4 things. So we've got the u, we've got the v, we've got the u dash, we've got the v dash. So now it's just a case of the product rule. Okay, so over here, product rule, dy by dx, which is us differentiating that original function y, is equal to uv dash plus vu dash. Now uv dash, okay, so I'm going to take my u, which is 2x, I'm going to times it by that complicated thing I've just worked out, which is 10x brackets x squared minus 1 all to the power of 4 plus, much nicer, 2 brackets x squared minus 1 all to the power of 5. Now I could just simplify this first bit at least, couldn't I? So 20x squared x squared minus 1 all to the power of 4 plus 2 brackets x squared minus 1 all to the power of 5. Let's leave it there. I don't really fancy doing anything else with that. That can be my final answer. Okay, so that's using the chain rule within the product rule. Okay, so hopefully that's been nice and straightforward there. Just have a little recap. So it all boils down to a product, okay, and this formula, which is the most straightforward version, which is really easy to remember as well. Okay, all right, any questions, please let me know. Okay, hope that's nice and clear. Good luck.